Vibration and impact analysis of optimized automotive front bumper. Abstract. This safety is the major concern in automotive engineering because of rate of accident increasing worldwide. Generally, in most of the accident during front collision bumper hits the other vehicle. The main function of front bumper is to absorb the possible crash energy during collision and should have low weight apart from the safety. In automobile industries, importance also given to fuel efficiency and emission gas regulation, that gives advantage to manufacturer in weight reduction of automotive. The main factor affecting bumper-like shape optimization, impact condition and vibration are studied for design and analysis of front bumper to improve crossworthiness. Here shape geometry is studied to design the optimized structure of bumper and impact behavior analysis is carried on it to find out energy absorption capacity, also easiness of manufacturing studied parallelly. In this research, impact dynamic behavior analysis of optimized front bumper without stiffener and with stiffener are carried out and compare their result against stress distribution, energy absorption, deformation, and found that bumper with stiffener have more energy absorption capacity. Experimentally validate the natural frequencies obtained from FFT analyzer with modal analysis using FIA software, and those are closely matched. While building the prototype, found that designed bumper structure is easy to manufacture too. Keywords: bumper, vibration, stiffeners, FIA. Introduction. World is now focused on the rapid developments in the various fields such as aerospace, space, automotive, electronics, and defense, infrastructure developments and power generation. Automotive sector has emerged as booster to the economy of nations over worldwide. Nowadays rate of road accident is increasing worldwide, so safety is prime important in automotive engineering, and automotive manufacturers are also looking to bring lightweight and fuel efficient vehicles in market. So, there is continual research on reducing the cost of vehicle as well as on improving passenger safety concerns. In automotive industries, factors, such as vehicle weight reduction and energy absorption through deformation but in a controlled manner of the frontal vehicle structure, is getting researcher major focus over the last few years. A bumper is frontmost or rearmost part of automobile, ostensibly designed to allow the car to withstand in an impact without causing damage to the vehicle's safety and other systems. During high-speed impact, they are not capable of reducing injury to vehicle occupants but being increasingly designed to mitigate the injury to pedestrians struck by cars. The ideal design of the bumper should take full advantage of the bumper plastic deformation to absorb most crash energy in automobile collisions. 1. The bumper structure designed to prevent or reduce physical damage to the front or rear ends of passenger motor vehicles in collision condition. They also protect other system of automobile. A good design of car bumper must provide safety for passengers and should have low weight too. During literature study found that automobile bumpers are designed to absorb the energy during front and rear impact of car such way that we can select best materials and geometry. It should possess the above two requirements with minimum price. 3. Although the use of lightweight parts helps in reducing fuel consumption and consequently lower carbon dioxide emissions, another stringent demand from the society is the passive safety obtained through energy absorbing bumper. 4. Automotive design with economy, safety, high fuel efficiency and aesthetics have been a great challenge to design engineers. In the actual product design, finite element analysis methods have been extensive used to replace the crash tests, and research results indicating the use of FIA software to simulate the real vehicle collision test has good agreement results with the real test, which can effectively substitute vehicle crash tests to conduct collision analysis. Computational tools of FIA helps in saving cost and time in studying economic design and enable alternative study on various materials and its properties under varying loads. So finite element analysis is considered for analysis in this work. In main objective of this work is to design an optimized and impact dynamic behavior bumper structure like crashworthiness by studying and analyzing different feasible shapes of front bumper along with other affecting parameters by using 3D modeling software and FIA software. In this work mild steel of 2.5 mm thickness is used to manufactured prototype of optimized bumper in order to find out its ease of manufacturability and to perform FFT analysis in order to find out natural frequency, and will try to validate FIA results with experimental results. 2. Research methodology. Based on comprehensive study and analysis of key parameters of bumper through various research literature, bumper standards, crash analysis, actual working conditions, the bumper structural model is established. The bumper structure is optimized and enhanced the crash worthiness by iterating the bumper structure by considering the different feasible shape geometry, thickness, manufacturability, and performing dynamic behavior analysis by using FIA software for every iterated modeled bumper structure till to get optimized bumper with better result. Also validated the improved natural frequencies obtained from manufactured bumper by experimentally with FIA software. 3. Geometric modeling of bumper. 4. FIA modal analysis of bumper. A. Optimized bumper. 1. Bumper geometry. V. Experimental analysis of bumper. Experimental analysis is used to find out natural frequency and mode shape of manufactured bumper. This is done by using fast Fourier transform, FFT, analyzer. In this experiment, we used small impact hammer, FFT analyzer, accelerometer, computer and DoSoftX software. Bumper was excited by impact hammer, preferably at a point near to the center location of bumper. The input signals captured by a force transducer, which is attached to impact hammer. The resulting vibrations in the bumper are measured by an accelerometer, which is mounted on the bumper preferably in the center area. These signals are subsequently input to the analyzer, which analyzes both input signal from hammer and output signal from accelerometer, and then resulting frequency response functions are then transmitted to the computer, which is having DoSoftX software for modal data analysis, which gives natural frequencies and mode shape data. A. Test frequency plot. 6. Experimental analysis results. A. Comparative plot of FIA. B. Test and FIA comparison. 7. Explicit dynamics analysis of bumper. A. Velocity of impact is considered as 70 km/h equals 19.5 m/s. After comparing energy summary graph for bumper with stiffener and bumper without stiffener, it is found that bumper with stiffener have more internal energy absorb capability for respective impact, and it is 1.82 times 10 to the power of 6th mj compared to 1.27 times 10 to the power of 6th mj. It is around 25 to 30% more. 8. Conclusion. In our research, we build prototype of optimized bumper to study the operation and found easy to manufacture. In this study found that natural frequencies obtained from our experimental and numerical result are closely matched at most of the modes. Addition of stiffener increased the natural frequency because it made the model stiffer, and geometry of shape also helps to increase natural frequency by using curve shape and avoiding sharp corner. From our impact dynamic analysis, we analyzed that the bumper model of optimized shape with stiffener having more energy absorption capacity and proposed to be best from safety point of view.